Alright, so one more time. When I do these problems, I really like to start with a picture, okay? So a mass is suspended from a spring. And the spring is compressed a distance of 4 centimeters, then released, okay? So I'm going to go ahead and just at least try and draw a graph, alright? So if this is time, then what we're going to do is see the spring bounce up. It is now bouncing just straight up and down, right? It is going straight up and down, but over time, as time goes, you're going to see it go back and forth, back and forth. But yes, if you were looking at it as a person, you would just see the spring go up and down, up and down, up and down, right? But over time, you're going to watch it go from 1 second possibly down, 2 seconds up. So we will graph it over time. That's why it's going to look like a cosine curve. Keep in mind, yes, it is oscillating back and forth, but it will travel across the screen in terms of time, okay? So I know that it's going to be compressed a distance of 4 centimeters. So I'm going to put 4 here, okay? And I'm going to start the spring up. So it's compressed. And then when I let go of it, it's just going to oscillate, all right? So then it's going to return to its original position after 1/3 of a second. So let's go then a 1/3 of a second. Then we'll have 2/3. Then we'll have 3/3 or 1 second, right? So it's going to look something like this. It's going to go down, come back up, and it returns after 1/3 of a second, right? And then it's going to continue this, okay? So if I want to do a nicer graph of it, I've got the nice graph paper down here, but at least having a picture of it, I can start to work on the equation, right? So first of all, I'm going to call it a cosine because it starts at its maximum. Its amplitude is 4. So we're going to use y equals a 4 cosine, okay? Because we start at 4, and then it travels down, and it gets the whole thing in 4 has an amplitude of 4. Now, to find the frequency b, it's always 2 pi divided by the curve width. Well, the curve width in this instance is 1/3 of a second. Well, I can simplify that. I know how to do a little bit of fraction work. That's going to be the same thing as 2 pi divided by 1/3, right? We're just going to do basic fractions. 2 pi times 3 over 1, which makes 6 pi, right? That's the frequency, which means you're going to get 6 pi up and downs in 2 pi, okay? So I'm going to go ahead and go 6 pi here, and we're going to have then x. There is no horizontal movement because we're at 4, and there's no vertical movement because we're right at the horizontal, okay? Now the last thing I'll do is change it so it makes sense in the problem. So we're going to have a height, so I'm going to go h of t, height of the spring over time, is equal to a 4 cosine 6 pi t. It's the only thing I want to change, the fact that it really has to do with height and time, not x and y, okay? So let's graph it. So if we graph it down here, we're going to have 1, 2, 3, 4. If I go by 1/3 of seconds, 1, 2, 3, 4, there's my 1/3. 1, 2, 3, 4, there's 2/3. 1, 2, 3, 4, there's 1 second, okay? So again, I'm going to take this shape and put it on my graph. I'm going to have it start at 4, and after 1 second, it's back to 4. Its minimum is down at 1/6 of a second at -4. Its x-intercepts are here and here at a 1/12. So it's going to look something like that. Here's 1. There's 1 revolution up and from down and back up. And I'm just going to do a few more of these. I want to get to 1 second because it'll make it really easy to answer that question, right? Here we go. Do it again. And of course it keeps going. So what is the position after 1 second? That's pretty easy, isn't it? 1 second's right here. The position is back to 4 centimeters, okay? So it goes back to 4 centimeters. Yep, you can. Now, I also want to show you how you can put this on the calculator, because it's always nice to have it on the calculator. I don't mind if you use the calculator as long as you know how. One of the things I do know is when you go to college, a lot of your college professors are going to expect you to know how to use the calculator, but they won't take the time to teach it. So I really feel like it's my job to actually teach you how to use the calculator, okay? So if I'm going to do this particular problem, there's a few things I need to know on my calculator. One, mode. We have to be in radian mode. Absolutely have to be in radian mode because of the 2 pi. You guys agree?
Yes.
Okay, you have to be in radian mode. My window, in this case, 4 to negative 4 on my y's, but we can go from 0 to at least 1 second here. Maybe we'll go a little bit more than 1 second. I'm going to go a little bit more than 1, maybe 2 seconds. You guys want to go to 0? So go 0 to maybe 2 seconds. We don't need to go anything behind because there won't be negative time in this case, right? We just hold it, start. There's no negative time at all, right? I'm going to go probably negative 5 to 5 on my y max and my y min so that I see the whole thing, right? Okay, now y equals, clear. We'll just go 4 cosine, and I'll go 6 pi x, because x is going to be t, right? I'll get rid of this one here, delete that, and I should be able to graph it and watch my spring. Here it goes.
That looks exactly like mine.
Yeah, pretty cool, huh? If I use my trace button, I can find out where it is at any particular time. There's 1 second and 4. What do you know? Gosh, that makes a lot of sense to me. So we can just watch the spring go back and forth, and we'll know exactly what height it happens to be at any particular time just by using my trace button, okay? Pretty easy, right? All right, let's take a look at the other side. You guys ready to turn it? Okay. Okay, we have a different problem. So, example 2. So, example 2 is at a latitude of 40 degrees. Okay, now we're about 48 degrees latitude, okay? If you're even higher up, you know, the higher up you go, you'll have either less daylight in the wintertime or more daylight in the summertime. Everybody right? I mean, if you were up in, say, Alaska, sunset right now for Alaska is probably, I'll bet, 3:30. It seems like 3:30 for us because we're in the mountains, but it is early, okay? Anyway, so at 40 degrees, the longest day of the year has 14 hours and 50 minutes of daylight, okay? And the shortest day is at 9 hours and 10 minutes, okay? So what I want to do before I do a whole lot of this problem is let's change these to decimals because I need to put them in my calculator. So I'm going to take 14 50 60ths, all right? I need to change that. And I need to take 9 and 10 60ths. I need to change both of these into a decimal, okay? It's going to help because this is time, all right? This is 50. If you put 50 in your calculator, that's like half. This is not half, right? This is much more than half. So I'm just going to use my calculator. What is 50 divided by 60? And I get an answer about 0.8333. So really I've got a 14.83, okay? And then 10 divided by 60, I'm going to get a 0.163, so I got a 9.16 repeated, okay? Now, let's go ahead and do this. So I'm going to start with January 1. You guys okay with that? January 1st. How's that? How's that sound? Let's start with January 1st. And then let's go through the calendar real quick. Oh, I might have to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I think I'm going to go every 2 squares is going to be a month. Otherwise I won't get the full year, okay? So I counted squares. 24 squares is right about here. I got 12 months. So, okay, I'm thinking, well, if everything's going to fit. So if that's January, then this is going to be Feb 1st, right? March, April, right? Put May in there. Have our June right here. Put our July, August. Put our September, October, November, and then December, okay? And then we're back to January 1 next year right there, okay? I'm going to darken these in so we can see them a little bit better. All right, there we go. Boom, 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 boom. Alright. Another thing I want to do is make sure I put my time in. So let's let this be daylight. This is my daylight here. Alright. And the very lowest is 9 and the very highest is 10. So if I go 2, 4, 6, 8, 10, that's not going to quite work. If I go by 3, 6, 9, that'll probably work, right? So if I go by 3s, this is 3 hours, 6, 9, 12, 15. Now we don't have to be perfect on our graph because we're going to make a perfect equation. Okay? And then we're going to put it in the calculator and have a perfect representation in our calculator, right? So let's go ahead and the longest day of the year. Where's the longest day of the year?
June 16th.
Yeah, so probably June 21st actually. June 21st is the longest day of the year, okay? Huh?
How do you know that?
It's summer solstice.
G-Day.
It's always June 21st. Or June, actually,
School that day.
it could be June 22nd, could be June 20th, but it's right around there. Okay, it's not an actual date. It's actually when the sun finally reaches its highest
Yeah. It's actually not summer. It's
and it starts traveling back.
Probably opposite of summer.
Right. It changes every year slightly.
Point on the longitude.
Right. Totally agree. But June 21st is pretty safe, okay? So longest day of the year is going to be at 14 hours. So I'm going to put a dot up there somewhere, okay? There's my 14. Shortest. When's the shortest day of the year?
Whenever the other one is.
December 21st.
Wait, so you put it in between June and July, sorry?
Did I? Yeah. So June 21st is about there, right? And then the shortest day of the year is December 21st. So we'll estimate just December 21st. In fact, you know what? Elise, I'm going to take your suggestion. I'm going to move my point slightly because I got it more on the 15th. I'll put it like, how about if I put it like right about there? Is that better? And then December 21st, I'll put it right about for, let's see, 3, 6, 9. How about right about there, okay? Now if I go back, then there's a December 21st here. You guys agree with that one? There's my December. So December 21st is maybe right about there, okay? It doesn't have to be perfect, but I can get a general idea of what the curve is going to look like, okay? How's that? How's that? Now, we can find an equation. We can. So let me go ahead and write down what we know. We're going to write y equals a trig. We're going to go x minus, whoops, I've got it wrong, b x minus h plus k. That is our equation, right? Keep looking at that over and over and over again. That is the main equation we need. Now, are we going to call it a cosine? Are we going to call it a sine? What do you want to call it?
Let's call it.
We can call it a cosine and start here. We can call it a negative cosine and start it here. It does not matter. But if you do a cosine, then you're going to have to really do a big shift, which is okay. We can do a big shift, all right? Okay, you want to do that? Or do you want to do a negative cosine and start here?
Yeah.
Okay, I'll do that. Let's do a negative cosine and start here, okay? So let's go y equals a negative something cosine. Let's just start right there, okay? Now the amplitude, Simon, the amplitude is max minus min divided by 2. So it's going to be my 14.83 repeating minus my 9.16 repeating divided by 2, okay? So I'm going to do that on my calculator. 14.83 minus my 9.16, and I get about a 5.67, okay? So my amplitude is about a 5.67, so let's put that right there. Let's go ahead, negative 5.67 cosine, all right? Now, to find b, b is 2 pi divided by the period. The period is the easiest thing to find of all on this one.
The year,
Yeah! Which is how many days?
365.
There you go. Isn't that the period? I mean,
5.2.
1 year from today, we'll have the exact same amount of sunlight, right? So, divide by 3.
Yeah, what if the sun disappears by the...
Anyway, moving on. So,
Like envelops the earth.
this is
We're not
a...
here by then.
Anyway, moving on. Okay. X. Now, in this case, we're going back, right? We're going to shift back. So we're going to go plus, okay? Because we're going to shift back. Now, you ready? How many days, it's super easy, how many days are from January 1st to go back to December 21st? We go from 31, the 31st day, back to the 21st day. How about just 10 days, right? There's 10 days from the winter solstice to New Year's. Okay, winter solstice is on the 21st. New Year's Day is on the 1st. How many days transpire? Just 10, right? You guys agree with 10? So we go plus a 10. Now the K. So to get the K, it's always going to be your minimum plus your amplitude. Our minimum here is our 9.16 plus our amplitude, which is a 5.67. Okay, so we're going to just take our 9.16 plus 5.67. We get about a 14.83, which, yeah, that's right. This graph has been shifted way up here. That actually makes sense to me because the graph has been shifted way up here. Okay, now we got an equation, right? Let me go ahead and circle that in there. There it is. Circle that in there. So now, find the amount of daylight at May 10th. Okay, now we got to do a little bit of math, but we're smart, okay? Now May 10th. May 10th is, I always like May 10th because that's my birthday. That's why I picked it. May 10th is right about here. How much does Mr. Davies have? How much daylight does Mr. Davies have, okay? Now, of course, granted, before anybody says it, we are not taking into consideration daylight savings time, okay? Don't even ask, okay? We're going to just leave that out of the whole equation, right? Because that'll really mess us up. Because then we'd have to, it would not change the amount of daylight at all. It would just change where the daylight happens to be. Yeah, anyway, whatever. So from January, how many days are in January? February, without a leap year.
28.
Good. March.
31.
April.
38.
To May 10th?
May 10th.
10, right? So what we want to do is this is going to be the day that we're going to plug in. So what day of the year is May 10th? I don't know. Let's just add them up, right? Add them up. We're going to go 31 plus 28 plus 31 plus 30 plus 10, 130. So May 10th is the 130th day. So I'm going to plug that into my equation, right? If I plug it into my equation, I'll find out how much daylight happens to be there. So I'm going to go ahead and we're going to do this. I'm going to plug it in. All right, clear. Now, for me personally, I'm going to do this. Watch, 2 pi divided by 365n. Okay, see what I did? Do you see what I did?
Yes.
I want to show you why I did this. So when I plug in my 140th day, I'm going to go negative 5.67 cosine of this answer. That is my 2 pi over 365, right? So much easier than trying to type in that in my calculator and be worried about parentheses and more parentheses. And then I'm going to go another parentheses, and I'm going to go my 130 plus 10, right? Parentheses. Parentheses, guys, close off, plus 14.83. That's what I get. So there's like 19 hours of daylight on my day. That's pretty cool. Yeah. Yeah. All right.
Wait, how is it 19 if the longest day has only 14? Yeah.
Yeah, there's something not right in here. I think it is this right here. I gotta go back to min plus amplitude, because that bumped it up quite a bit.
That can't be because the longest is 14 hours and that.
Yeah, let me push the play button off and I find out what I did wrong.